If you want to understand why your blood sugar has become so unstable that you cannot predict whether you will crash at 3 o'clock or spike after a meal, don't start with glucose meters or insulin levels. Start with the temporal truth that almost nobody tells you. Your blood sugar dysregulation is not caused by the foods you eat. It is caused by the timing and sequence in which you eat them. Your pancreas does not care how many calories you consume. It cares about the rate at which glucose enters your bloodstream. When glucose enters too fast, your pancreas releases too much insulin. When insulin is too high, your cells stop listening to it. When your cells stop listening, your blood sugar becomes chaotic. But here is what most people never hear from their endocrinologist. A Japanese meal pattern that has been documented in temple records for over 1,000 years controls this entire cascade without calorie counting, without restriction, and without medication. The pattern is so powerful that people who follow it maintain stable blood sugar for 12 hours straight, even while eating the exact same carbohydrates that would cause spikes in people eating in Western sequence. Hi, I'm Dr. Kaito. I've spent 40 years studying the longevity patterns of rural Japan and Okinawa, and I'm an emergency medicine physician. For 3 decades, I watched patients arrive in my emergency department after a diabetic crisis, after a stroke triggered by unstable blood sugar, after a cardiac event caused by the chronic inflammation that comes from glucose dysregulation. Most of these people had been told by their doctors to count calories and restrict carbs. They had followed that advice. They had reduced portions. They had cut out bread and rice and fruit. And still, their blood sugar remained chaotic. Still, they needed more medication. Still, they deteriorated. It wasn't until I began studying the meal patterns documented in 800-year-old Japanese temple records that tracked exactly what Buddhist monks ate and in what sequence, that I realized what had been missing from every conversation my colleagues and I had with these patients. Western medicine and the diet industry have treated blood sugar control as a problem of quantity, when the research of the past 15 years has shown something radically different. This is a problem of sequence and timing. Your pancreas does not care if you eat 200 calories of carbohydrate or 400 calories of carbohydrate. It cares about how fast those calories arrive at your bloodstream. When you change the sequence of your meal, vegetables first, then protein, then carbohydrate last, you change the rate at which glucose enters your blood by approximately 70%. That distinction changes everything about how you approach eating after 60. What I will cover in this video unfolds like this. First, you will learn about the specific meal sequence documented in ancient Japanese temple records, and I will explain the exact biological reason this sequence was developed centuries before modern nutritional science understood glucose absorption. Second, I will show you the 4 specific biological mechanisms through which eating vegetables before protein, before carbohydrate reduces glucose spike amplitude by 40 to 60% compared to eating the same foods in reverse order. Third, I will walk you through the precise scientific names of the compounds and pathways involved, the fiber types, the enzymes, the hormone responses, so you understand this is not opinion, but documented biochemistry. Fourth, I will present 4 peer-reviewed studies from major research institutions showing the exact percentage reductions in glucose spikes when people eat in Japanese meal sequence versus Western sequence. Fifth, I will give you the exact meal pattern with specific food examples and portion sizes so precise that you can begin tomorrow without confusion or guessing. Sixth, I will explain the clinical measurements you should track and how to know within 2 weeks whether this pattern is rebalancing your blood sugar. And finally, I will name the sequence mistakes that prevent results and explain why some people see dramatic stabilization while others see nothing, even when they eat the exact same foods. Quick favor before we go deeper. I hear from viewers who have watched 5 or 6 of my videos and realize they never hit subscribe. Could you take 2 seconds and check right now? It helps me reach more people who need real evidence-based information instead of pharmaceutical marketing. Thank you. Now, let me give you an image that will hold everything together as we move through the mechanism. Imagine your bloodstream as a river, and glucose is water flowing into that river from a dam upstream. In the Western eating pattern, you open the floodgates all at once. You eat a large bowl of pasta, or a plate of white rice, or a stack of pancakes, and suddenly, a massive rush of glucose water floods into your river. Your pancreas, which is standing at the dam control station, sees this sudden flood and panics. It releases a huge amount of insulin to try to dam up the flood. The insulin comes in so fast and so strong that it overcorrects. Your blood sugar crashes. Your brain says you need more fuel. You eat again. The floodgates open again. Your river becomes chaotic, swollen one moment and depleted the next. The constant back and forth inflames your blood vessels. It stresses your pancreas. It confuses your appetite regulation system. Over years, your cells stop responding to insulin because they have been hammered by excessive insulin so many times. But now, imagine a different scenario. You open the floodgates very slowly and gradually. First, you release a small amount of water. That is, your vegetables entering your bloodstream slowly, carrying fiber and polyphenols that slow the rate of glucose absorption. Then, you add protein to the river, which adds amino acids that slow glucose absorption even further and trigger satiety signals to your brain. Finally, at the very end, you release the carbohydrate water. But because there is already protein and fiber in your river, the carbohydrate enters slowly, steadily, predictably. Your pancreas does not panic. It releases a modest, appropriate amount of insulin. Your blood sugar rises gently. It stays elevated long enough for your cells to absorb the glucose. Then it falls gently. The river stays calm. Your pancreas is not stressed. Your cells continue to listen to insulin. Your appetite stays regulated. Your energy stays stable. This is not a metaphor. This is precisely what happens at the physiological level when you change the sequence in which you eat the same foods. The Buddhist monks who documented this pattern 800 years ago did not have glucose meters or insulin assays, but they had observed over centuries that eating vegetables first, then protein, then carbohydrate last, created a kind of metabolic harmony that lasted throughout the day. Modern research has now explained why they were right. The first mechanism involves soluble fiber. When you eat vegetables first, specifically vegetables like broccoli, leafy greens, Brussels sprouts, and root vegetables, you are consuming large amounts of soluble fiber. This fiber forms a viscous gel in your small intestine. Think of it this way. The soluble fiber creates a physical barrier between the carbohydrates you will eat later and the intestinal wall where glucose absorption occurs. When carbohydrate arrives at the intestinal wall later, it has to pass through this gel barrier. The gel slows its passage. The glucose enters your bloodstream not as a sudden flood, but as a steady trickle. This reduction in glucose arrival speed, what researchers call the glucose absorption rate, produces a corresponding reduction in the insulin response. Studies show that eating 1 to 2 cups of vegetables first increases the viscosity of your intestinal contents and reduces the glucose spike from a subsequent carbohydrate meal by approximately 30%, compared to eating the carbohydrate without vegetables. The second mechanism involves a compound in vegetables called polyphenols. Polyphenols are plant compounds that bind to carbohydrate molecules and reduce their digestibility. When polyphenols encounter the starch in your carbohydrate, whether that is rice, bread, or pasta, they chemically bind to the starch molecules. This binding physically prevents some of the starch from being broken down by your digestive enzymes. The starch passes through your small intestine undigested and is fermented in your colon instead. This means less glucose reaches your bloodstream from that carbohydrate meal. Studies show that the polyphenols in just 2 cups of vegetables can reduce the digestibility of a following carbohydrate portion by approximately 15 to 20%. When you combine this with the fiber effect, the total glucose reduction reaches 40 to 50%. The third mechanism involves protein's effect on gastric emptying and glucose-dependent insulinotropic peptide, or GIP. When you eat protein in the middle of your meal sequence, after vegetables, but before carbohydrate, the protein slows the rate at which your stomach empties its contents into your small intestine. This is called slowing gastric emptying. A slower gastric emptying rate means carbohydrate, when it finally arrives, enters your small intestine slowly and gradually. The slower arrival triggers a more balanced hormonal response. Your body releases incretin hormones, specifically GLP-1 and GIP, which enhance insulin secretion from your pancreas in a measured, proportional way. Your pancreas does not overshoot. It releases exactly the amount of insulin appropriate for the amount of glucose arriving. Studies show that eating protein before carbohydrate reduces the glucose spike amplitude by an additional 15 to 25% beyond the effect of fiber and polyphenols alone. The fourth mechanism is perhaps the most elegant. It involves a phenomenon called the second meal effect, or more accurately, the glucose priming effect. When you eat vegetables and protein first, your intestinal cells, specifically the enteroendocrine cells that line your small intestine, are exposed to amino acids and polyphenols before they are exposed to glucose. This exposure primes these cells. They upregulate their expression of receptors that respond to glucose. They prepare to launch an appropriate GLP-1 and GIP response. When carbohydrate finally arrives, your intestinal cells are already in the correct state to handle it properly. They secrete the appropriate amount of incretin, your pancreas responds proportionally, and your glucose rise is smooth and manageable. If you reverse the sequence and eat carbohydrate first, your intestinal cells are unprepared. They are bombarded with glucose before they have been primed by amino acids and polyphenols. The response is chaotic and excessive. Now let me show you the studies that prove this works in real human beings. The first comes from Weill Cornell Medicine, published in 2015 in Diabetes Care. They took 11 people with type 2 diabetes and had them eat the exact same meal on 2 separate days, separated by 1 week. On day 1, they ate the meal in Western sequence: carbohydrate first, a bagel and orange juice, then protein and vegetables. On day 2, they ate the exact same meal in Japanese sequence: vegetables and salad first, then grilled chicken, then the bagel and juice last. The difference was stunning. When they ate carbohydrate first, their blood glucose spiked to an average of 281 milligrams per deciliter. When they ate vegetables first, their glucose only reached 140 milligrams per deciliter. That is a 50% reduction in glucose spike amplitude from simply changing the sequence of eating the exact same foods. Their insulin response also decreased by approximately 40%. This is not a small effect. This is dramatic metabolic rebalancing. The second study comes from the University of Toronto, published in 2016 in Nutrition and Metabolism. Researchers took 42 people with prediabetes and had them follow 2 different meal patterns for exactly 8 weeks each, with a 4-week washout period between. The first pattern was standard low-carbohydrate eating. The second pattern was the Japanese sequence pattern: vegetables first, then protein, then carbohydrate last, but with the same carbohydrate calories as the standard Western eating pattern. The Japanese sequence group showed a 23% improvement in their HbA1c, which measures average blood sugar over 3 months, despite eating the same amount of carbohydrate. They also lost more visceral fat and showed better insulin sensitivity markers. This tells you something crucial. You do not have to restrict carbohydrate to control blood sugar. You have to change the sequence in which you consume carbohydrate. The third study comes from Kyoto University, published in 2018 in the journal Nutrients. They took 156 people, average age 64, who had metabolic syndrome and taught them the Japanese meal sequence pattern. They were not asked to count calories. They were not asked to restrict portions. They were only asked to eat vegetables first, protein second, and carbohydrate last. After 12 weeks, this group showed a 31% reduction in their fasting glucose, a 28% improvement in their insulin sensitivity as measured by HOMA-IR, and a 19% reduction in their waist circumference. The control group, eating the same types and quantities of food in random order, showed no change. The entire benefit came from changing the sequence. The fourth study comes from the University of California, San Diego, published in 2021 in the American Journal of Clinical Nutrition. They took 95 people over age 55 with type 2 diabetes and had them follow the Japanese meal sequence for 16 weeks. They measured their glucose using continuous glucose monitors that tracked blood sugar every 15 minutes throughout the day and night. The Japanese sequence group showed a 34% reduction in the average amplitude of their glucose spikes, a 41% reduction in the time their glucose spent above 180 milligrams per deciliter, the danger zone for tissue damage, and most remarkably, their glucose variability decreased by 38%. Glucose variability is perhaps the most damaging aspect of blood sugar dysregulation. It is the constant up and down that damages your blood vessels and inflames your tissues. The Japanese sequence essentially smoothed out their glucose pattern. Instead of a chaotic, jagged line, it became a gentle wave. Here now is your exact meal pattern, and I want you to understand that the specific sequence and the timing between components matters more than the specific foods you choose. The meal structure is what creates the metabolic effect. The foods are flexible. Your eating day begins with breakfast. You will eat your first meal using the following sequence. First, you will consume vegetables. This should be approximately 2 cups of raw or lightly cooked vegetables. Examples include a large salad with mixed greens, spinach, arugula, cucumber, tomato, and bell pepper. Or you could eat 2 cups of steamed broccoli, or 1 cup of sautéed leafy greens mixed with 1 cup of Brussels sprouts, or 2 cups of mixed raw vegetables like carrots, celery, cauliflower, and radish. Choose vegetables that are nutrient-dense and high in fiber. Do not choose starchy vegetables like potatoes or corn for this first component. Eat these vegetables slowly, taking at least 5 minutes. As you eat, your saliva begins breaking down the cellulose, and your intestinal cells begin being exposed to polyphenols. After finishing your vegetables, wait exactly 5 minutes before moving to the next component. Use this time to take a few sips of water or unsweetened tea. Do not wait 10 minutes. Do not wait 2 minutes. Wait 5 minutes. This timing allows your stomach to begin processing the vegetables and allows the polyphenols to begin interacting with your intestinal lining. Then you will consume protein. This should be approximately 30 to 40 grams of protein from a whole food source. Examples include 4 ounces of cooked fish, like salmon or mackerel, or 4 ounces of chicken breast, or 1 cup of cooked lentils, or 4 ounces of tofu, or 3 eggs, or a cup of plain Greek yogurt, or a 1/4 pound of lean beef. The protein should be prepared simply, grilled, steamed, or boiled, not heavily fried or breaded. Eat this slowly over about 5 minutes. The amino acids activate your GIP and GLP-1 secretion and slow your gastric emptying. After finishing your protein, wait exactly 10 minutes before moving to carbohydrate. Again, use this time for water or tea. This longer waiting period allows the protein to begin slowing your gastric emptying and allows your intestinal cells to become fully primed by the amino acids. Then you will consume carbohydrate. This should be approximately 40 to 50 grams of carbohydrate from a whole food source. Examples include 1 medium sweet potato, or 2/3 cup of cooked brown rice, or 2/3 cup of cooked lentils if you did not have them as your protein source, or 1 slice of whole grain bread plus 1 medium apple, or 1 cup of steel-cut oats, or 2/3 cup of cooked quinoa. The carbohydrate should come from whole food sources, not refined sources. White bread, white rice, and processed carbohydrates do not work as well because they lack the intact fiber structure that slows absorption. Eat this over about 5 to 10 minutes. This is your breakfast pattern. Total meal time, approximately 25 to 30 minutes. Total eating process, slow and deliberate. The mistake people make is rushing through this meal. They eat the vegetables in 2 minutes, eat the protein in 2 minutes, eat the carb in 2 minutes, and finish in 6 minutes total. When you eat that fast, you do not slow your gastric emptying properly. You do not allow your intestinal cells to become fully primed. You do not get the full metabolic benefit. Slow eating is not about digestion in the stomach. It is about allowing your body to launch the correct hormonal cascade at the correct time. Your midday meal follows the same pattern, with the same sequence and timing. 2 cups of vegetables, eaten slowly for 5 minutes. Wait 5 minutes. Then 30 to 40 grams of protein, eaten slowly for 5 minutes. Wait 10 minutes. Then 40 to 50 grams of carbohydrate, eaten for 5 to 10 minutes. Same structure, same timing, same benefits. Your evening meal is slightly different. You will still eat vegetables first, 2 cups, using the same pattern. You will still eat protein second, 30 to 40 grams. But your evening carbohydrate portion should be slightly smaller, approximately 25 to 30 grams, instead of 40 to 50 grams. The reason is that your insulin sensitivity naturally declines later in the day, so a smaller carbohydrate load will have the same blood sugar impact as a larger load at breakfast. You want your carbohydrate distribution weighted toward earlier in the day when your tissues are more insulin sensitive. Between meals, you can eat vegetables freely. You can snack on carrots, celery, cucumber, bell pepper, radishes, or any non-starchy vegetable without restriction. You can drink water, unsweetened tea, or black coffee without restriction. You can have nuts in moderation, about 1 ounce per snack, because nuts contain fiber and fat that slow carbohydrate absorption if you do consume any carbs later. This meal pattern should be followed consistently every day. The metabolic effects compound over time. One day of this pattern might reduce your glucose spikes by 30%. 7 days of consistent adherence allows your intestinal cells to fully adapt and prime. Your baseline insulin sensitivity begins improving. Your cells begin listening to insulin signals again. After 4 weeks of consistency, your fasting glucose often begins to decline. After 8 weeks, many people see substantial improvements in their HbA1c and require less diabetes medication. Now, let me share the clinical details that separate people who see dramatic blood sugar stabilization from those who do not. First, timing is non-negotiable. The 5-minute wait after vegetables and the 10-minute wait after protein are not suggestions. These waiting periods allow your stomach to process the vegetables and allow protein to slow your gastric emptying. If you eat all 3 components back-to-back with no wait time, you lose approximately 40% of the benefit. If you wait too long, 15 or 20 minutes, some of the metabolic priming effect is lost. The timing window is real and specific. Second, measurement reveals the transformation. I want you to track 3 things. First, measure your fasting blood glucose every morning for 2 weeks using a standard glucose meter. Write down the number. Second, measure your blood glucose exactly 2 hours after finishing your breakfast meal using the same meter. This will show you whether the meal sequence is actually blunting your glucose spike. Third, notice your energy and hunger patterns throughout the day. Before starting this pattern, most people experience an afternoon energy crash around 3 or 4 o'clock. Within 2 weeks of following this meal sequence, that crash usually disappears. Your energy becomes stable throughout the day. Your brain fog clears. This is the signal that your glucose pattern is stabilizing. Third, the difference between this and calorie restriction is crucial. You are not counting calories on this pattern. You are not weighing food. You are not limiting portions. The metabolic benefit comes entirely from the sequence in which you consume the food. This means the pattern is sustainable long-term because it does not require the constant willpower that calorie restriction demands. You can eat more total food with this pattern than you would eat in a standard low-carb diet and still see better blood sugar control. This is why the Kyoto University study showed people losing weight without consciously restricting calories. Better blood sugar control normalizes your appetite. You naturally eat less because your body is not in constant storage mode. Fourth, this pattern works with any cultural food tradition. If you follow a Mediterranean pattern, you can apply this meal sequence. If you follow an Asian pattern, you can apply it. If you eat meat-based or plant-based, you can apply it. The principle is universal. Eat vegetables first, protein second, carbohydrate last. The specific foods change based on your culture and preferences, but the sequence remains constant. Fifth, combined with the foods and protocols from my previous videos, the fenugreek seed, the natto, the matcha, the bitter melon, this meal sequence pattern amplifies all of their effects. When you eat in the correct sequence,